And we're back with another problem about limits and whether or not this limit exists. So while we may be thinking about Mean Girls and the limit does not exist, in this case the graph of function f is shown and we want to know when the limit does exist. So this is condition number 1. This must be true, the limit must exist, and also f must not be continuous. So two things going on here. How could a function not be continuous? Well, a function is not continuous at a vertical asymptote. A function is not continuous if there's a hole in the graph. A function is not continuous if there's a jump in the graph. A function is not, and I think that's about it for what we really need. So we are looking for a limit existing, which means the limit as x approaches b from the negative direction from the left must equal the limit as x approaches b from the right. So the limit must exist, but actually when we get to the b, one of these things that's not continuous. And before we get there, if this is going to be true, I already know that a vertical asymptote probably is not the case, but let's just see what's going on first. Okay, so what's going on in this case? This graph is kind of complicated. A couple things going here. Here's my vertical asymptote. Here's my hole, and here's my jump. So it's probably going to be true at one of these, and then not true at another one. So I have a vertical asymptote, a hole, and a jump. Let's just go one by one. -1. When x is equal to -1, first condition, does the limit exist? Well, the limit from the left looks like it's going to -infinity. The limit from the right going to +infinity. The limit does not exist. -1 is not my solution. Letter B. When x is 0. At 0, what is the limit from the left? The limit from the left looks like it's 2. The limit from the right is also 2. So far, that one checks out. Is the function continuous at 0? No, there's a hole there. It's not continuous. This is true for both conditions, and my correct answer is letter 0. But let's continue to see why the other ones are not. Letter C, 1. At 1, is the limit from the left equal to the limit from the right? Yes, it is. Is this discontinuous at 1? No, it is not. So it's good for the first condition, but it does not meet the second condition. It is not good. At 2, does the limit from the left equal the limit from the right? No, it does not. So this cannot possibly be the answer. And at 3, does the limit from the left equal the limit from the right? Yes, it does. So that's good. But is it discontinuous at 3? No, it is not. So that cannot be the answer. The only correct answer here is letter B, and that is just a quick little review of limits.